This is the test track that we're using on our phase 1 of the automation of an HO scale train, and I just want to point out some of the hardware features that are involved in the automation of this track. It's a very simple back and forth test track, about a little over 2 meters in length. And this item here is the brains of the whole thing. It's a Arduino Pro-Mini, and then the inputs to the Arduino are 2 ultrasonic sensors. This is one of them, and there's another one at the other end of the track. And these are US-015 sensors, and they work quite well for determining the distance of the train from the end of the track. And for controlling the train motor, we're using PWM and a L298N motor control board over on the other side of the track here. And the whole operation is powered by 12-volt DC battery, which you can probably see off here. And that's about it. We wanted to keep the hardware as simple as possible, and the motor control board drives the track with a pulse width modulated 12-volt DC signal. So we're not talking DCC here, we're only talking DC with pulse width modulated voltage appearing on the track, which the Arduino is able to control and accelerate the train and decelerate it, and also reverse direction at the end of the track. Okay, now I'll swing the camera so you can get an idea of the whole track. So we got 2-meter rulers running from each end of the track toward the center, and I've got a diesel locomotive at the end of the track there, which is at the starting position, and a boxcar which is pushing. Okay, so that's the test track, and the only electronics at the far end is the ultrasonic sensor down there. So now we will connect the battery to supply 12 volts to the system. And you're probably able to see the blinking LED down here, and the steady LED a little higher than that. The steady one is simply a power on indicator for the Pro-Mini board, and the blinking LED indicates that it has arrived in the start state from a power up situation. And the way we get out of the start state is either by pushing this push button right here, or using an IR remote to activate the IR detector, which is right here. So now I'll push the start button, and train's coming down the track, and there's the boxcar arrived. And we'll try to follow it back to the other end. It's going to go 4 trips down the track. That's 2 of them. Here's the 3rd trip. We got a variable delay before the train starts back. It's actually a random delay. And this is the final stop position. There's only 4 passes. Of course, it's software controlled. It can be changed to any number of passes you want in the cycle. And we can look at both LEDs on the Arduino, and they're both on. The bottom one indicates that it's in the stop state, and it'll remain there until I push the button again. This is another view of the test track in its entirety, and a new LED is visible in this video. Let me connect the battery and start it using the IR remote. Okay, now for the IR remote. And you can see the new LED. It's in the middle of the track, and it indicates when the Arduino is accelerating or decelerating the train. So here it starts accelerating from the far end, and then when it detects the sensor, it'll stop, it'll decelerate. Here's the acceleration away from the near stop. And the detection and the deceleration, variable delay. And you can see both LEDs lit, indicating the stop state, so I'll have to restart it. And it'll start another 4 trips here. This is 1. So this third LED gives a lot more insight into what the Arduino is actually doing and when it's doing it. Indicates the deceleration state and the acceleration state. And we just entered the stop state. Okay, thanks for watching.